Hi, everyone. Thank you for joining us today for the Data Lakehouse webinar. My name is Mary Kirshner, and I lead customer success here at Focal CXM. Before we get started, I wanted you to all know that we will have time at the end for any questions or comments. So please post your questions to the Q&A link, and we will address them at the end of the presentation. Today, we are excited to delve into the recent innovations in Data Lake's architecture. We are very happy to have Venkata Jyothi Kotra with us today. Jyothi is the Director of Data and AI at Focal CXM and oversees the data and AI solutions in both the commercial and public sector. Additionally, she serves as an adjunct faculty member for data analytics at South New Hampshire University. Jyothi has extensive experience in data modernization, architecture, governance, enterprise modeling. She's a pioneer in next-gen tech solutions and is well-versed in big data, cloud computing, distributed data processing, system upgrades, and business process transformation. Thank you so much for being here with us today, Jyothi. I will pass this on to you.
Thank you, Mary, for the introduction. Thank you, everyone, for joining today's webinar. I am Venkata Jyothi Kotra. I appreciate you all taking time for the webinar presentation on Data Lakehouse and how it simplifies data engineering, analytics, and artificial intelligence in a unified platform. Here is a quick peek at the agenda and topics to be discussed in today's webinar. First, we will talk about the evolution and complexity of data in today's modern world, and Data Lakehouse and evolution of Data Lakehouse and the elements of well-architected Lakehouse, and end with the Q&A session. A little introduction about Focal CXM. Focal CXM is dedicated to enhance employee and customer experiences through utilization of data, artificial intelligence, and Salesforce. Focal CXM has achieved success in delivering diverse data and AI services to esteemed clients and stakeholders. In continuation, I would like to emphasize that Focal CXM and Databricks are trusted partners. They play a crucial role in advancing Lakehouse architectures and also enabling organizations to harness data effectively. And while maintaining the trust and compliance, customer obsession is our key. Before delving deep into the Lakehouse platform and its benefits, I would like to talk about the history and evolution of data and the complexity of data management. Early in the days of data management, data management was truly through databases and data warehouses. Data warehouses were used to collect, store, and analyze data. For many years, data warehouses were sufficient for the enterprise or company to manage the data because the amounts of data stored was relatively small. Data warehouses were simple, reliable, with structured data. With the rise of internet, digitalization, modernization, and also cloud adoption by many organizations, the quantity of data produced and was not sufficient for a single data warehouse or database to manage. This led to fragmented stores of data across the organization. And data warehouse also was not providing any support for other data formats like video, audio, or text. And there's no support for data science and ML use cases because most of the advanced analytics and algorithms needs computer vision, which is visual based images, and also audio files. So these use cases were not being served by data warehouses. At the same time, the data warehouse became a closed and proprietary format. It only serves the SQL based interfaces. So the organization needs a mechanism or a way to serve the data and AI use cases. That's where the data lakes evolved. Data lakes can handle all the data formats. It's an open format system, and where data science and ML use cases can be built on top of data lake. However, data lakes, it is an open, low-cost storage solution, but it provides minimal support for business intelligence use cases. Aggregation and summarization on data lake is a nightmare, and also it's very complex to set up, and poor optimization and performance because reading and writing back to data lakes is not as easy as data warehouse, and a mismanaged data lake can immediately turn into an unreliable data swamp, and managing the data lake is not so easy. With the organization having these challenges, it soon realized that having data lake and as well as data warehouse is really important to serve both business intelligence, analytics, and AI ML use cases. So, what are the management challenges running these two disparate architectures? Companies realize that tangible value of data decision making, data driven decision making, operational efficiency, and real time insights are very, very important for the enterprise. And 32% of the companies report tangible value from the data. And most of the studies showed that 80% of organization data by 2025 is going to be unstructured. And it is very crucial for AI use cases. So data warehouse definitely cannot support this, and data lake is must and should. And at the same time, the tool stacks to maintain two disparate architectures, both data warehouse and data lake, which leads to incompatibility between these architectures. And at the same time, data redundancy and duplication between these two systems, which leads to data drift issues. And at the same time, there's challenges in collaboration between the teams because data lake is a different format, semi-structured or unstructured, which needs a different tool stack altogether to flatten or normalize the data. Whereas data warehouse is a structured and more normalized structure. So the two teams with two different tool stacks and two different governance altogether leads to inconsistent governance also, because governance needs to be established both in the data lake and as well as data warehouse. So with the given challenges, the next question raises is how to get best of these both worlds. Both are as equal important for the organization to maintain the data management as a single platform. That's where data lakes comes in. Data lakehouse comes in. Data lakehouse, in a simple terms, is a combination of data warehouse and data lakes. It takes good from both the platforms. Data lakehouse takes good elements of warehouse like metadata management, ETL processes, schema, lineage, all good elements from data warehouse. And it takes good elements from data lake, especially the openness. Openness means supporting semi-structured, unstructured, and structured data, and support for any formats, data formats. So combination of both creates data lakehouse, which sits on top of data lake, and it provides all the important features of data warehouse. So the name itself, it says that lakehouse is combination of both. It supports AI ML use cases from the ground up, and it is highly reliable and performant. It runs on a distributed processing system like Spark, so it runs petabyte scales of data in fastening light seconds. And it's a single approach for managing data. It provides support for data engineering, warehousing, data streaming, AI, ML use case, everything in the single platform. So it's easy for any organization to adopt data lakehouse. So moving on, how Lakehouse combines this data lake flexibility and also structure of data warehouse. Lakehouse is very, very important newly enabled system design, which implements the data structures and management features from both the worlds. So what is Delta Lake? And what are the key features of Delta Lake? Delta Lake is an open source project which is built on top of data lake houses. And it takes all the important combinations of warehouse. The key features, I would talk about some of the key features over here, which is ACID transactions. ACID stands for atomicity, consistency, isolation, and durability. Any transaction which is run on Lakehouse architecture is atomic in nature, which means that an operation would be run as a whole or operation wouldn't run at all. And it is very consistent in nature. This leads to prevention of data loss or prevention of corruption. Any operation which is stopped in between creates data loss. So atomicity and consistency maintains the data integrity of the platform. Isolation is another important key feature. Any operations which are run on Lakehouse platform against the Delta tables, all those operations are isolated in nature. Any concurrent queries, concurrent users, all this would run in isolation as a whole. So it maintains durability of the transactions within the Lakehouse. In addition to that, another important feature is scalable metadata handling. This whole Lakehouse platform is built on top of data lakes, which is run, background engine is Spark. Spark is a distributed processing system which can scale to any billions of files or billions of rows of data very easily. And it can read and write petabyte scale data. So the scalable metadata handling is one of the important feature of Lakehouse platform, which brings the processing power to the whole platform. And Schema enforcement and evaluation. I cannot emphasize enough on how important this feature is. There's an important concept saying stop enemies at the gate, which means that data quality is laid from the ground up. Starting from the data ingestion itself, the quality is maintained. So schema enforcement makes sure that there's no inconsistency formats of the schema itself. Data types, inconsistencies, any data quality errors are early on detected, and then it enforces the consistency of schema. And in cases where it needs to evolve the schema, then evaluation will right away evolve the schema. And other than that, other important feature is time travel and auditing. So here I'll quote an example over here. For example, a data scientist have built an AI ML model using a table which is coming from a feature which is coming from a table of version 46. And then the AI ML has been deployed as a real-time endpoint. Everything is working well. There's a new code change, and the code version has deployed table version 47. And then suddenly something breaks. So even while root cause analysis is done, troubleshooting is done, Data Lakehouse platform provides time travel feature, which means that right away the table can be rolled back to version 46 and previous state can be established right then and there while the root cause analysis is being happening. So time travel is one of the important feature and most it utilized feature of Lakehouse platform. It maintains auditing, it maintains rollback, so comes in very handy for the data engineers and data scientists. In addition to that, I already talked about the openness of the platform itself. It accepts any data formats. And updates and deletes, Data Lakehouse platform handles merges, updates, deletes all in just like in capacity of warehouse. In addition to that, it accepts any change data feeds, upserts, and then any change data feed, meaning that incremental feeds it can accept right then and there within the pipelines. So, nevertheless, there are many key features of this Data Lakehouse platform, and then it supports all the consumers with the good advanced features. Okay, we heard a lot about the features now. Now, how about my current architecture is AWS, or my current ecosystem is Azure, or maybe Informatica is running my current system? Do I need to change my ecosystem, or do I need how can Delta Lakehouse integrate right away into my platform? That's one of the important question. Flexibility and integration is another key over for Lakehouse platform. Delta Lake by itself can integrate easily for any major analytical tools and any ingestion platforms, whether it is Fivetron, Informatica, pre-built connectors are established for Delta Lake. Not only that, any data storage layer can be supported to Delta Lake, meaning S3, blob storage, ADLS, Gen 1, Gen 2, or Alibaba Cloud. Any data storage layer can easily, flexibly integrate with Data Lakehouse. Moving on to one of the important component of Delta Lakehouse architecture, which is data engineering. Data is a strategic asset for revenue growth, customer experience, operational efficiency of our enterprise. And data teams heavily rely on getting the right data at the right time for business intelligence use cases or AI modeling. So data engineering is very important component. And in the current architecture, which needs to maintain a data warehouse and data lake separately, there are a lot of data engineering challenges which are to be taken into consideration. First, explosion of data volumes and types. With this modernization, digital era, and cloud adoption, there's a lot of data which is being produced by each and every domain of the organization. In addition to that, there's a lot of data types, numerous amounts of data formats. So, any single platform handling a consistent way all these volumes and types is not an easy thing. In addition to that, there's a need for integration of multi-cloud environments because for an organization, the data might come from third-party tools, which where one tool is in AWS, one tool may be a GCP, Google Cloud provider, and another data source might live in Azure. So integrating all these multi-cloud environments and maintaining the tech stack and code stack for all these integrations is not an easy task. In addition to that, given the complex data ingestion methods, so most of the use cases might be batch loading. Some of the use cases might be streaming of data because real-time analytics is like evolving day by day, and it is so important to keep real-time insights for matching the competitive advantage. So complex data engineering methods, the platform needs to support that. In addition to that, modern data engineering principles. Today, the world is agile in nature. Software development lifecycle is turned completely agile, which means you build it, you deploy it. Fastness is key over here. So the platform needs to support all these important challenges at the same time. Performance tuning. I cannot emphasize enough how important performance of these data pipelines needs to be. And how do Lakehouse platform help this modern data engineering simplified? This Lakehouse platform provides end-to-end engineering solution for ingestion, transforming, processing, scheduling, and delivering data. It automates building and maintaining pipelines and running ETL workloads on Data Lake. It is a unified platform. Very, very important key feature over here. Like everything runs on a single platform, so it's easy to manage. And it is declarative in nature. I'm going to talk about Delta Live tables in my next slides, but Delta Live tables are declarative ETL framework, which is one of its first kind on Lakehouse platform. Easy to code, low code ETL solution. And at the same time, the workflows, which are very important for schedule and orchestration, the workflows are integrated right within the Lakehouse platform, and there is no need to search for any third-party tool to maintain the orchestration of the data pipelines, like Apache Airflow or Luigi. That workflows easily mimic the same structure of Apache Airflow, and it provides an end-to-end solution for unified and batch streaming. Batch load can happen in the same platform, and streaming use cases can also run in the same platform, which gives an ease for the data engineering team. And last but not least, it's compliant in nature. It meets all the security and regulatory standards. So it can integrate with any data sources for that matter, whether it is like a databases, relational databases, streaming sources, no SQL sources. It can integrate with any data sources and make any data consumers happy by providing data in a near real time for BI use cases, machine learning, or any data products. Moving on to the important feature of Lakehouse, which is Delta Live tables. Delta Live tables are the first ETL framework which have been introduced on Lakehouse platform, which is declarative in nature. It auto scales, which means that once a pipeline has built on Delta Live with the functions, Delta Live functions, then it auto scales, which means that based on the need of the data, if it is millions of rows, the data source, then immediately it auto scales and raise the clusters up. And if the need is not there, it scales down, and which maintains the cost efficiency nature, and it runs on serverless architecture. So cost efficiency is key over here. In addition to that, it allows for full data refresh or incremental refresh. Both are supported on Delta Live tables. Incremental computation is another important feature, which means that Delta Live tables can be set on a triggers. A trigger can be time based or event based. Any new file in a storage location like S3 or Azure Blob, the immediately Delta Live pipeline detects that event, that there is a new file modified timestamp, and it triggers the pipeline right away. That is the ease of Delta Live pipelines, how it orchestrates. There's no need for an engineer to sit and monitor the pipelines. It has automated triggers by itself. And checkpointing and retries are another important key feature. So if there's like 500,000 XMLs which needs to run right away into the data pipeline, then checkpointing is key feature. It runs the pipeline in chunks, and it keeps checkpointing on how many files have been loaded. Hourly checkpoints can be established, or even the checkpoints can be any time frame for that matter. And retries. In event of pipeline failure, it can do a retry based on a set amount of time limit. So with this all important features or capabilities, the Delta Live tables come to the platform. It is integrated with repos, which means that any code which is built can directly have a version created in GitHub. Easy integration to GitHub. And it supports Unity Catalog. So Unity Catalog is a governance platform which is in the Data Lake. So with all these important capabilities of Delta Live tables, let's move on to talk about medallion architecture. What is medallion architecture? Here, the Delta Lakehouse platform maintains the data flow in layers. The first layer is raw layer, which is called bronze layer. Bronze layer is a landing zone for raw data. Basically, an enterprise can offload all of its data into bronze layer and maintain all the data over here. There's no need of any structure, there's no need of any schema. It is a landing zone where data can be landed as is. And from there, the transformation logic, cleansing logic, augmentation, filtration, all these are enabled in the silver layer. So the silver layer is mainly where the schema enforcement, structure enforcement, all these rules starts to kick in. And from there, gold layer is the semantic layer or aggregated layer which serves the BI use cases, or it is also a feature store which serves the AI/ML use cases. So gold layer primarily is built as a semantic layer to support analytical use cases. So a question comes in: do I need to maintain my data in three states? Do I really need copies of my data in three layers? Yes, it is needed for sure to maintain the reliable and performant platform. Reads are very easy from an aggregated or semantic layer. So if a business intelligence report needs to be built and it is integrated to a silver layer, which is more transactional in nature, the performance is going to be impacted a lot. At the same time, if the bronze layer directly my pipeline needs to write directly to the gold layer, then writes are very slow on gold layer because it is an aggregated in nature. So with having this both combinations, it's something very similar to how a warehouse is established, OLAP and OLTP. The same warehouse key elements have brought into the Lakehouse platform where bronze, silver, gold layer, a three-tier architecture is built. And data quality is enforced start from the beginning, and quality just gets improved, moving as the data flows from layer to layer. Okay, now we have built our pipeline with a good architecture and all that is done. Now, how can I orchestrate my data pipelines? Data orchestration is another important feature because they need to run on a cadence, and nevertheless, orchestration needs to happen starting from ingestion of my raw data, from there, doing some transformations cleansing, and then turning them into aggregations, features, and then it needs to support my AI/ML model. So all these tasks are needs to be run for an end-to-end use case to be done. So all these tasks, individual tasks, can be orchestrated through a workflow. So workflow usually maintains these tasks as dependencies. So unless the highest dependency task is met, the pipeline wouldn't flow to the next task. So dependencies can be established, integrations can be established very easily, and it is an easy platform to monitor the progress of the pipelines. And this mimics same like if all of you are familiar to Apache Airflow or Luigi, it is very similar, where orchestration of pipelines can be monitored through a graphical interface. And workflows can easily integrate with any task, irrespective if the task is a simple SQL query which serves a Power BI report. That can also be orchestrated. And it can be run in a specific cadence, whether it's hourly or daily or monthly. And it can integrate to autoloader, Delta Live tables, or any task for that matter. And it can integrate with any platform. Moving on to one of the most important capability of Delta Lakehouse, streaming of data. Organizations today are facing a challenge in analyzing vast amount of streaming data. The data is being produced through multiple systems like mobile, IoT devices, click streams, application events, database data feeds. So all these are real time in nature, and taking decisions, organization decisions on this real time is must in this competitive world. So to keep up with innovation, the organizations must quickly make sense of this data. And then all the IoT devices, smart application, clickstream applications, instant product recommendations, all these use cases need data to stream in live, and real-time analytics needs to be built on the platform. So Lakehouse architecture brings in the streaming use cases in five different patterns. The first pattern is streaming ingestion. Streaming ingestion is event driven. So any events which are created in the databases or event streams, then they can right away be ingested into the Lakehouse platform. And ETL can be supported using Spark structured streaming, which is built on Spark SQL, or and Delta Live Tables can also support the streaming use cases. So any higher level abstraction for streaming pipelines that can be easily handled on Lakehouse platform. In addition to that, event processing. So it just acts as enterprise message hubs, or data hubs. So any message which is created, the message streaming can happen in real-time cadence with low latency using Spark architecture. And the applications can be built as event driven and ML inference. So most of the ML pipelines which are deployed through Delta Lakehouse as ML flow, as real-time inference pipelines, they all can be maintained easily using this Lakehouse architecture. And also, like, there's a quick snippet on how Delta Lakehouse serves different use cases like live dashboards, real-time queries, alerting, fraud prevention, and etc. etc. So we talked about performance a lot, and distributed processing a lot. How is it even possible on Delta Lakehouse platform? What is the backend engine which is making this? That's where Photon comes in. Photon is a engine which is purposefully built for performance on the Delta Lakehouse platform. Photon is a query engine which offers cost saving and speeding up of all use cases. Initially, it was built for warehouses. And then the Photon support started to increase to Spark APIs, Python, and any open format of data. So right now, all the Lakehouse platform is served through Photon. So any submission or any task which has been submitted, then immediately the Photon kicks in and it provides fastest data processing engine and runs seamlessly without any code changes. So there's no need to specific configuration or anything. Just turn the Photon on, which is a toggle button, and immediately this kicks off, and then the whole process runs very fast. So the studies shows that customers see up to 80% of total cost savings using Photon than the traditional Databricks. And the runtime engine shows like 85% reduction in VM computers using this Photon. So moving on to another important question, like what about the security of this platform? So Data Lakehouse actually divided the whole security and providing permissions into two different planes. The first plane is control plane. It manages the workspace application, notebook, configuration, and clusters in a control plane. And all the permissions can be granted and given and maintained easily using Unity Catalog. And at the same time, data plane process the data within the cloud service, and encryption is provided for the data at rest and as well as data in transit. So when the data is stored in a data storage layer in DBFS or ADLS or S3 locations, already the data is encrypted at rest. And when the data is in motion, flowing through layers and layers, all the data is encrypted. So it supports all the important security checkboxes for majority of the platforms, and then it satisfies the AWS IAM identity access management, Azure Active Directory, and GCP identity. Any cloud provider for that matter, the security standards are established. In addition to that, it supports the compliance standards like SOC Type 2, HIPAA, GDPR, CCPA, or it is also FedRAMP. Moving on to another important component about warehousing. How does Lakehouse converge this data lakes and warehouses? And data warehouse by itself is already present in majority of the companies. Do we need a data warehouse on Lakehouse platform? Yes, because the current data warehouses, traditional data warehouses, struggle to keep up with evolving technologies, and it is mostly structured. But emergence of non-SQL languages, non-SQL databases, unstructured data, machine learning, IoT devices, streaming, all this necessitate for a more performant data warehouse. So the data warehouse, which is inbuilt within the Lakehouse platform, is a unified serverless multi-cloud solution. And it has a built-in governance. It is a single source of truth for all the data with unified governance, and all layers across all the data is which is single source of truth. It simplifies architecture by establishing a single copy of data across all the analytics, ETL, or AI ML use cases. And it provides the easy discovery and security and management of all data. All this is through Unity Catalog. Unity Catalog provides easy discovery of data assets. And in addition to that, it has a built-in SQL editor. So the one of the key feature I would like to highlight here is within the Databricks workspace itself, there's a IPython notebook where users can write directly the code in Python to actually do the querying and coding. And at the same time, it also has a SQL editor. So users who are well versed with SQL and used for many years writing SQL like SQL Server, then there's right away a SQL editor within the Lakehouse platform. So easy querying, and right away that results can be turned into visualizations and dashboards. And there's a partner connect, which is a simplified solution where the tables can right away connected to Power BI or Tableau or any analytic solution for that matter. So it provides an end-to-end solution for modern analytic needs. It has a rich ecosystem and easy integration for any analytic downstream systems. So it breaks down data silos, and all the data can be onboarded to data warehouse, which runs on Photon, which we talked about previously, which is a fast query processing engine. So it optimizes queries right then and there so that the queries can run faster and serve the analytical needs. Moving on to the next topic, data governance. So again, I cannot emphasize enough how important high quality data is and how important is to govern the data. Recognizing the need for accessible data, actionable insights, and business value, all this is possible when the data is governed better. Duplication of data, risks of the data, enough security is not established can lead to data breaches, impacting the brand value and customer trust. So, governance is crucial for secure data management. So, what are the key challenges of data and AI governance when there is two disparate systems like data warehouses and data lakes and not a unified platform? So there is increased need for use of data ASS. Data is not simply structured anymore. There's a lot of data produced in semi-structured and unstructured formats. And the studies show that nowadays this unstructured data is the key because structured data needs a lot of storage. So there's a lot of difficulty in managing all these diverse data assets. Any third-party tools or the traditional legacy data governance tools like Colibra, Talent, they cannot handle most of the use cases. So there is a need for a unified governance platform. And in addition to that, multi-cloud adoption, which means that within an org, within the data architecture, within the data platform, it is not just simply one ecosystem. It is a multi-cloud ecosystem. So having governance solution established across these clouds, maintaining all the standards of cloud, AWS, Azure, GCP, and maintaining governance models across the platforms is not an easy thing to do. And with this disjointed tools for data governance, fragmented tools using one tool a solution over here, and for the next, there's another tool for maintaining governance and data lineage, managing all these data assets is simply going to turn into a very robust, very tiresome process. So that leads to the next topic, which is Unity Catalog. This is one of the important feature of Lakehouse platform, which provides a uniform governance solution. So it is a unified solution established on Lakehouse where governance can be established starting from the ground up, from the metastore level itself, the workspace metastore, from there going into the catalog level. From the catalog, once a permission or a permissions authorizations and identity access management has been established at the catalog level, that access can cascade down to the columnar level, which is a fine grained access controls. For example, let me give an example over here. There would be two types of users for a use case who needs to query the same table, but one of the user group can see a PII column, but the other user group cannot see the PII data. But the same table needs to serve both the user groups. In that case, Unity Catalog has fine grained access control, which is called column masking. So column masking can be enabled. So the user group role-based access can be established where the user group with sensitive data access can have the query resulted with PII data, and when the user group who have restricted access, they cannot see that column altogether. So that is the level of access which can be controlled using Unity Catalog. And in addition to that, the Unity Catalog provides a built-in data dictionary feature. It is AI enabled, where when a table is created right away, AI just suggests like this table comment and as well as column comments. So it's very easy to build in a data dictionary right then and there with the table. There's no need to maintain data dictionaries, external data dictionaries, but it is right built in then and there. In addition to that, there's automated data lineage. So whenever a Delta Live pipeline has run, it automatically creates a graphical representation of data lineage. So when a critical data element is established, starting from the origin to the target, each and every transformation of that critical data element can be tracked through this lineage graphs. So there's no need of any external governance tool like Colibra or Talent, but inbuilt data lineage can be established. And trusted data sharing can be enabled using Unity Catalog. And when the within the org, when there's two different workspaces, still with Unity Catalog, all that can be managed at a metastore level, and whole domain can be easily accessed and controlled through Unity Catalog. So with that, let's move on to another interesting topic on Lakehouse platform, which is Lakehouse IQ. So with this Lakehouse adoption, already it is like a force in the market where many organizations are moving to Lakehouse architecture. With this, there's a rapid raising technology which is Gen AI. Generative AI is integrated within the Lakehouse, and generative AI with generative AI, there's a Lakehouse IQ which is built, which is a knowledge engine across the whole enterprise data. As soon as the enterprise data is onboarded into Lakehouse, then Lakehouse IQ kicks off where it learns the whole enterprise data, the nature of the data, domains, and relationships. Everything is learned by the Lakehouse IQ. And it goes across the Lakehouse objects, not just simply the tables, notebooks, querying. When data engineer is trying to run a code, immediately Lakehouse IQ says, oh, this table is reading from multiple files from Azure Blob. Why don't you just run optimize command on this so that optimization on table can happen? At the same time, the Lakehouse just suggests, why don't you run in-memory cache so that the processing is faster? So Lakehouse just works as a colleague next to you, where colleague is giving suggestions on improving the processing. Lakehouse IQ is just like that, colleague next to you, which supports each and every activity. Same with data scientists or data engineer, any persona who is working on the Lakehouse architecture. It interprets, aligns, and gives actionable insights for the team. At the same time, for any in-product search, like this is a use case, what I need to best use, then immediately it suggests the right product, what to implement for that. So Lakehouse IQ just tries to find, understands all the activities which are running, and then it immediately tries to give a response which saves hundreds of hours. At the same time, it is very cost effective in nature. It helps users run their data processing needs faster. And then it also provides insights like what table is the most popular table and who are frequent users on the table. And it gives insights on quality of the tables, quality of the data. So Lakehouse IQ is like a friend. Uh, Coming on to the final topic, which is data intelligence lakehouse platform. So with this lakehouse adoption, there's and also combination of Gen AI, it makes the lakehouse data friendly and architecturally exceptional. So here, the main elements of intelligent lakehouse. First, I would like to talk about Delta Lake. Delta Lake accepts any kind of storage formats. It's open in nature. Any data formats it can support. And it is a unified data storage for reliability and sharing. Then next comes in the Unity Catalog, which is a unified governance platform. And then the intelligent platform, right away using Unity Catalog, it securely gives insights on every operation which is being performed on Lakehouse. And then it tries to suggest on different actions by itself. Then using this data intelligence engine, they can be different data bricks, SQL tasks developed. At the same time, workflows helps in running all the jobs at a low cost, and orchestration is easy. And at the same time, with Delta Live Tables, real-time analytics is possible. At the same time, they serve all the ETL needs. And then Mosaic AI, which is one of the revolution of Lakehouse platform. Mosaic AI is a vector database which can serve all the Gen AI use cases, and then it serves the customer LLMs very easily, and fastable and scalable searches. So with all this capabilities of Lakehouse platform, let's stay tuned for our next webinar. Today we have discussed about the benefits of utilizing Lakehouse platform, and particularly this webinar was focused on data engineering and warehousing. For the next webinar, we'll cover more about machine learning and AI on this Lakehouse platform and what are the critical components. And next webinar will also concentrate on Mosaic AI, which I just talked about, ML flow, and trusted data sharing. With all this, I would like to extend my gratitude to all of you for participating in the webinar. It was an absolute delight to virtually meet each and every one of you. Thank you so much.
Well, thank you, Jyothi. We really appreciate you taking the time to share your in-depth knowledge with all of us. Just so much information there, and we are looking forward to talking to each of you down the road on any additional questions that you have. There are a couple of questions that we have right now, and if there's any additional ones that people have, they can enter them into the Q&A at the bottom. But we have a few minutes left, so we'll try to field a few of these questions. The first is, how does the Lakehouse integrate with the customer's cloud architecture?
Yeah, as I mentioned, Lakehouse is multi-cloud, easily integratable to multi-cloud adoption. So it has like right away pre-built connectors because Lakehouse is directly built on Databricks, which can support AWS, Azure, GCP, or any native cloud for that matter. It runs on Spark, so it has easy integration for any cloud platform or cloud provider.
All right, thank you. The second question is, how does data mesh related to the data lakehouse?
Data mesh is a decentralized architecture. Data lakehouse can also be decentralized, which meaning like there can be multiple lakehouses running within an org. So each and every domain can maintain a lakehouse platform, which gives a data mesh like similar architecture. And lakehouses is unified in nature, but it can run separately within a domain itself. They can be set up so that still decentralization can be maintained, and it doesn't need to be a single platform for all domains within the org.
Okay, there's another one. How are bronze, silver, gold tables different in data warehouses and data lakehouses, or are they the same?
Bronze, silver, and gold tables in data warehouses also most of the time, like transactional tables are something which are similar to silver tables, and then the gold tables are nothing but analytical tables or summarized tables. So most of the time, bronze table in a traditional warehouse is a mix of both bronze and silver, where raw data, which is like there's a JSON, for example, or XML, for example, which are not parsed, those are raw data. But when we land that data directly into data warehouse, they already need to be normalized or flattened. So a traditional data warehouse would be like a silver and gold, whereas the lakehouse architecture has a bronze, silver, and gold, which maintains three tier.
All right, thank you. I think that's it for the questions that we have right now. Just want to thank everybody for joining again. It was really a pleasure. And we will download this recording. And so if you need to go back and review any of that, you'll have the option to access that as well. So thank you so much. And we look forward to seeing you at our next webinar.
Thank you so much.